All right, so this is 35. It says a certain race car has a maximum speed of 240 miles per hour. Which of the following is an expression for the maximum speed in feet per second? Right, so we need to change from miles per hour to feet per second. And then it tells us a little clue here in case we don't know how many feet are in a mile. It's 5,280. So if I have 240 miles per hour, for 1 hour, right, and I want to put this in feet per second, I'm going to change miles into feet first. So if 1 mile, it told me, is this many feet, I'm going to put that number on top, 5,280. This is in feet. And then, so now my miles and miles will cancel, and now I'm in feet per hour, right? And now we want seconds instead of hours. So if I think about this, an hour is 60 minutes. So 1 hour, I want to put this one on top because I want them to cancel. 1 hour is 60 minutes. And then we don't just want minutes, we want seconds. So I'm going to go ahead and put 1 minute in seconds is 60 seconds. This is going to help my hours and hours to cancel, minutes and minutes to cancel. And now if I'm looking for the units that are on top, the only one that's not canceled is feet, and the only one on bottom that's not canceled is seconds. So now I know I have feet per second, which is great. That's what I want. Obviously there's like a lot of ones here that I don't need. So I would have 240 times 5,280. And then I don't need the ones. And then 1 I don't need. And then 60 times 60 on the bottom. 60 times 60. So I'm going to look for the answer choice that has the same thing that I have. So I see 240 and 5,280 on all of them except D. D doesn't have that on top. And then 60 times 60, I'm going to double check on my calculator. I have a good guess, but let's see, 60 times 60 is 3,600. So I want the bottom to be 3,600. And the one that I see is this one here, C. Right, so I can see that that one matches my problem here. And that is number 35. For number 36, it says a chemist needs 1 ounce of element X. The only way that the chemist can get element X is to buy compound Y, which contains 10% X. So it's like 10% of X and 90% of something else. Compound Y costs $2.40 per pound, which is 16 ounces. How much must the chemist pay in order to ensure that she receives 1 ounce of element X? Okay. So if I'm thinking about this, I know that I have 10% is X and 90% is something else, right? And I need to get 1 ounce of this, right? It sells in 16 ounces, and I need to get 1 ounce. So if it's 10% X, then 10% of 16 would be 1.6 ounces. So like 0.1 or 0.10 times 16 would give me this much. So 1.6 ounces of X comes in a 16 ounces total, right? So I get 1.6. So I know it's less than a pound. I don't quite need a pound, right? If it's 10% and I want to get 1 ounce, then I need like 1 ounce of X would give me 10 ounces of the total, right? So 1 ounce to 10 ounces total. So if I want 10 ounces total, I don't want the full 16 ounces. I only want 10 out of the 16 ounces. So I know that I want 10 out of the 16 ounces, and I know 16 ounces costs me $2.40, right? So I need to know how much 10 ounces is going to cost. So I'm going to cross multiply. I get 2400 equals 16x. Divide by 16. I get 24 divided by 16, 1.5. So x equals 1.5. So X was how much it costs for 10 ounces, which is what I need in order to get 1 ounce of X. So this is the cost for 10 ounces, which would be 150 H. Now that I'm looking at that, that seems like kind of complicated, so I'm thinking about another way that I might be able to solve this problem.